Okay. We started compounded amounts, section 5.2. And I stopped right before effective rates. Effective rate most books use this for effective rate. It's also called APY, which is annual percentage yield. A lot of times on MyMathLab, they'll ask for the APY. What it is the annual compounded rate needed to produce the same amount of interest in 1 year. As the nominal rate does with more frequent compounding. So if you had one rate that's compounded quarterly, another rate that's compounded monthly, and another one semi-annually, you can't compare them because of the way they're compounding. But if you find the effective rate of each one, then you can compare them. And that's what effective rate allows you to do. There'll be two formulas, one for the compounded amount and one for compounded continuously. So that's our two formulas. Compounded monthly, daily, annually, quarterly, you would use this one. Compounded continuously, use this one. Okay. Number 31. It says find the APY corresponding to the given nominal rate. what we'll do is we'll do 31 and 32, but we'll find the compounded one, and then we'll also find the compounded continuously. I think they have them mixed in the story problems. I'm not sure, but that way then we have them together. So 4% compounded annually. Whoops. Semi-annually. Semi-annually would be a compounded amount. How many times a year is semi-annually? Anyone? 2. That means our M is 2 and our R is a rate written as a decimal. Let me just plug it into this formula. It doesn't say what to round to, so we will round the percent to the 100th. Oh, we don't have to round this one. Are you getting 0.0404? Now this is a rate, it's not the percent. So if we did have to round, it wouldn't just be 0.04. You have to make it a percent first. Then you would round. So it's 4.04%. Using the same problem, let's find 4% compounded continuously. Is everyone getting 0.0408107742? Well, depending on your calculator, I don't know how many decimal places it goes, but we want to round the percent to the 100th. So first we make it a percent. And the 100th would be here, 4.08%. So if you have a 4% interest rate compounded semi-annually, you're making approximately 4.04% per year. If it's compounded continuously, you're making a little more, 4.08% per year. But by finding the effective rate, you can compare them. Any questions on that one? Let's try number 32. So find the effective rate of 6.6% compounded quarterly and round it to the 100th. Now the percent should be close, but it should be higher. So you should be getting an answer that's a little over 6%. Does anyone want, once you round it to the 100th, what are we getting? Go ahead and type it into the chat. Yes. Compounded quarterly, our M is 4. 6% as a decimal, 0.06. And when we plug this in, we get 0.0613635506, making it a percent here. Round tens, hundredths. Oh, I wrote something wrong. I wrote too many threes. Tens, hundredths. The 6 will round this up. 6.14. Okay, go ahead and find 6% compounded continuously. Point 0.06183654 here. This 8 would be the hundredths. This is a 3, so this will stay at 8. 6.18%. Any questions on the compounded amounts? Okay. Let's try number 37. Find the present value of the given future amounts. So remember, these are, let's see, 4% compounded quarterly. So it's a compounded amount. A equals P times 1 plus R over M to the MT. We're looking for present value. That's your P. We're given future value. Remember, A is future value. So we want to plug these in and solve for P. 17,230 is the future value. So that's our A. P is what we're looking for. R is your rate as a decimal. 4% would be 0.04. Remember, just divide it by 100 or move the decimal to the left 2. Compounded quarterly. We said quarterly was 4 times in a year. 4 times the number of years, which is 10. Now, if you wanted, you could solve this first. I know that this divides and becomes 0.01. So I might combine that. But I know I need to divide it to the other side. And then you can just plug all of this into your calculator. Whenever you're talking about money, round to the nearest penny. Now, some of these problems will say round to the nearest penny, and others will say round as appropriate. If it says round to the nearest cent, you round as you normally would, and this would be an 8. This problem, they would probably state round appropriately, simply because if we drop this off, we're not going to hit the 17,230. We're going to fall short. So we would need to round the 8 up. So most of the time when you're looking for present value, if it doesn't say round to the nearest cent, then it probably wants you to decide if you need to round up or not. If you have present value and don't round that up, you're probably not going to hit your 17,000. So what I mean is if we found, put for P, this is an 8. Because that's what we were saying it was. If we put this in, it's probably going to come short. Now, rounding it might reach it. Yeah. Oops. We come a little short. Not much. A penny, but it's short. So we're supposed to get 17,230. We got $17,229.99. So present value, you need to round up. This comes a little bit short. But if you look at their wording, you'll know. Any questions on that one? Let's look at 43. I start right. Wanted to make sure I was recording. Yeah, I did. I thought I did. Okay, number 43. For 43 and 44, assume an annual inflation rate of 2.7%. So 2.07, which means R is 0.0207. Find the previous price of the following items. And we said 43. How much did an item cost if it's 5,000 now, 4 years prior? So now it's 5,000. Previously, we want to know what it was. So we're looking for the present value 4 years ago. If it's 5,000 now, that means that this is your A. And we're looking for P. What was the present value 4 years ago? Now it's 5,000. Whoops, I lost my P, be careful. Our rate as a decimal, 0.0207 divided by compounding. It was an annual. Yeah, it's an annual inflation rate, so once a year. And years was 4. We're solving for P, so we want to divide this to the other side. This is another one. This is the present value. So we'd have to round up, or we might not hit future value, which was 5,000. So you would round this to 57. Luckily, because it's an 8, we would have rounded it to 57 anyways. Any questions on that one?
So if we're talking about inflation, or unless it says otherwise, are we always going to use the compound interest formula?
If it says compounded amount, and this one was an annual inflation, so inflation is a compounded amount.
Okay.
So if it's inflation or says compounding amount, then you would use this, either case. Mm-hmm. Inflation is a compounded amount. It's compounded annually. So if you're using inflation, then your M is 1. So compounded monthly, quarterly, daily, annually, you would use this formula, and inflation is a compounding. It's yearly. Was 43. 46. I guess we didn't really talk. What inflation is, they do surveys across the United States. And for so many months, you keep track of all your spending, car payment, house payment, food, clothes, everything you spend, you keep track of how much it costs. And then the next year you do it again, and they see with, I don't know, probably hundreds of thousands of people, Americans, how much it's gone up or down. And that's how they find an inflation rate for a year, is by these surveys. And so number 46 says the annual inflation rate is 1.18%. Usually it's approximately 2% a year, but the last couple years with COVID, it's been, it was 5% a couple years, and then this past year it was a 7% increase. And I'm sure you're seeing it in gas prices, food prices, everything's gone up. But that's what the inflation tells you on an estimate how much most items will have gone up. Let's look at number 46. If the annual inflation rate is 1.18% annually, means our M is 1. And we have to write our percent as a decimal. How much did an item that's $1,250 now cost 6 years ago? So $1,250 was the future value. We're looking for how much it was worth 6 years ago. Divide it to the other side. Here, and of course, again, because this is present value, we need to round up or we won't hit our 1250. The keywords to watch for MyMathLab is if it says round to the nearest cent, use normal rounding. If it says round, I think it says on here, round accordingly, I think is how it said it, because someone had sent me a picture the other day, and that's because it needed to be rounded up. So it's just in the wording. Any questions on that one? Can't get to the bottom to change the page. There we go. Is there any questions on this one? They're not too bad. Once you know the formula, just be careful where you plug things in. Remember to put your percent as a decimal. Number 49. A small business borrows $50,000 for an expansion at 6% compounded monthly. The loan is due in 4 years. How much interest will the business pay? So we know it was compounded monthly. So we know it's this one. If it was simple interest, it would say that. Okay, so we have this. Now you have to decide where things go. You're borrowing $50,000. That's how much it is right now. That's present value. Um, 9% as a decimal. Compounded monthly. What would compounded monthly be? Yes, there's 12 months in a year, so monthly is 12, and that's what your M is. It's how many times it's compounded in 1 year. So this would be 12. And they said 4 years. This would give us the total amount at the end, not the interest. $50,000. You should get $71,570.27. So if you take a loan for $50,000 for 4 years compounded monthly, this is how much you'll pay in the end. The total amount paid. To find the interest, just subtract what you paid, because it was worth $50,000. If you paid this much, subtract them, and that's what you paid in interest. They also call this total contribution. When we get into house payments and things like that in the next chapter, they'll call it your total contribution. So the total contribution to the loan was $71,570. The interest was $21,570. Any questions on that? Okay, number 63. Use the approach from example 8 to find the time it would take for the general level of prices in the economy to double at the average annual inflation rate. So this is saying it's compounded annually. So we're looking for T. Since it's saying annually, M is 1. R is my rate. I'm going to look at number 63. R is 3% as a decimal, 0.03. T is what we're looking for. But they didn't give us A and P. They told us, though, they want it to double. Well, whatever this one is, this has to be double it. They don't have to give you an amount. You can pick any amount you want. You could put 1 here and doubled, it would be 2. You could put 100 here, doubled would be 200. It's up to you. But whatever's here, this will double because it wants the economy to double. We could put 100. 0.03 divided by 1. If this is 100, then we want to find out when it's 200. So when they're asking for how long something takes to double, they don't have to give you a value. We would divide by 100. Any questions on that part? Notice the variables in the exponent. If you recall from chapter 4, when we had a variable in the exponent, what did we do on both sides so we could bring that variable down? Anyone remember? Natural log, yes. If we take the natural log of both sides, then we can bring this down. So we have the natural log of 2 equals t times the natural log of 1.03. And then we can just divide by 1.03, the natural log of it. Depends on what they want. They didn't say what to round to. About 23.5 years. This is probably another one. Be careful. They may want it rounded up, even though this was a 4. Because dropping that off, we won't necessarily double. So if it says round the year to the 10th, it'd be 23.5. If it said round accordingly to the year, it would be 24, because 23, it will not have doubled yet. It's got to go a little further through the year, almost halfway through, before you double. So this is another spot where you would want to round up.
When you get to the point where the equation is like 2 equals 1.03 to like the t power, can you just do log base 1.03 of 2 equals t and then go from there?
Okay, you can. But the calculator doesn't have log base 1.03. Well, some of them do.
Yeah, mine does, but you can do like the division thing with it too.
Right, change a base. Oops, this is still in the exponent. By using the base of this value, there's a formula, log base b of b to the x. You can think of these as canceling, they just leave x. So if you do that, then this cancels and just leaves t. And then if your calculator will allow you to use this, you can. If not, you'd use change of base, because all calculators are base 10. which is then the same thing we had here.
Well, I didn't take it of both sides. I just know that like how to move the equation to put it into log form, if you know what I mean.
Yeah. Oh yeah, you just rewrote it.
Yes.
Yes, that is fine.
Okay.
There's a lot of different ways of solving them. I try and find the easiest ways to remember, but there are other ways you can do them, and I'm fine with them. Let's I think the one on the test I did compounded continuously. So if we have 5% compounded continuously, how long does it take to double? Remember, compounded continuously, that's A equals P e to the RT. We're looking for T. R is 0.05 because I said 5%. And then we just know whatever P is, the other one needs to double. Now, if you want, you can make this a 1. R was 0.05. As long as whatever this is double. Or you could leave this P. This has to be 2P. And then you divide it. Now you can just rewrite if you can rewrite it, or to get rid of the exponential function. Remember, the natural log of e to the x is just x, they cancel. So if we take the natural log of both sides, this cancels and leaves 0.05t, and then divide by your decimal. $13.9. I got this. Rounding to the 10th, you'd put a 9. This would be, if you round to the whole year, 14. If you're rounding to the 100th, you would round that 6 to a 7. So 13.9 years. Any questions on that? No. Okay. That's everything. Did you need to try another one of these? I'm almost positive I put on the final compounded continuously how long it takes to double. Is there any questions on those? Is there any questions on the finance project? No. Yes. If there's any work that you haven't done, you still can complete it. You have till the last day of classes. Any questions on that?
I actually do have a question about the finance project.
Okay.
Is there any way you could pull up the like directions? It's hard for me to pull it up while I'm on Zoom.
I'll bring it up.
Thank you.
Under here. And it's due November 20th. It's worth 50 points. There it goes. Okay.
You may have explained this, but what is MSRP?
Oh, that's the manufacturer's selling price. So whatever they're selling the car for. Like,
Okay.
Yeah, when you go onto a dealership online, it'll say MSRP. It's just the selling price.
Okay, thank you.
You're welcome. Any other questions on it? The finance for the monthly payment, we'll learn that on Monday. I think that's the only thing we haven't learned. When you are doing it, whoops. Oh, I guess that's good that it both came up. You'll do a sheet like this, a flyer for both cars. But remember, you don't have to show an insurance rate because most companies want to know all your private information. And then you'll have a paragraph that answers these questions. Any questions on that? Okay. If you do not have any questions, then have a wonderful weekend. Thank you.